back. Today we're going to be looking at electric field lines. So from the previous video we discussed what is electric field strength. So now we're going to be looking at the directionality of the electric field. In other words, where it's going to point to. So electric field lines are imaginary lines along which a positive test charge would move. Now, a test charge is always positive, and that's been given for historical reasons. So we're always going to look at it from point of view of a positive test charge. So let's go right ahead and let's actually explore the different cases and the different scenario and how to actually draw electric field lines. So we go, of course, back into our sketchbook. And the first one that we're going to do, we're going to look at point charges. So, as a general rule of thumb, a good way to remember this, of course, is PONI. So that stands for, of course, it stands for positive out, and I stands for negative in. So this gives us the directionality of how you're going to draw the field lines. So let's go ahead and let's check this out. So let's say we have a point charge. So the first one we're going to look at, of course, is going to be positive. So as we look at the mnemonic, we see that it's positive out. So you're going to draw electric field lines, and of course, because there are vectors, they're going to be represented by arrows, and you're going to draw the arrows going out, because why? Positive electric field lines always go out. So you're going to draw as many as they want you to draw, as many as the question asks you to draw. So if they say 4, you're going to draw 4 lines. If they say 3 or 2, you're going to draw 3 or 2 respectively. Now, there are 2 rules of thumb for this one. The first one is they have to come out of the surface of the point charge, and they have to be 90 degrees with respect to the surface. So as you can see over here, all of them are 90 degrees. They're all right angles, 90 degrees. And field lines, you can never, ever, ever cross them. In other words, this can never touch, for example, that one. So those are really the only 2 rules that we basically have with this. So let's look at a negative point charge now. The mnemonic tells us that negative is in, so you're going to draw now arrow vectors that are going to point in. And again, I do my best drawing on the tablet to actually show you that, again, they're 90 degrees, and these field lines over here do not cross. So that, of course, is our first one. Those are your point charges. They're very, very nice, simple, and easy to do. So the next thing we're going to look at, spheres. So again, the same exact concept, however, small change. So let's say, for example, the first one, okay, we have a negatively charged sphere. So all the charge is going to accumulate, let's say, for example, on the surface. So when we draw field lines, remember, PONI, positive out, negative in. So when we draw field lines, again, the same rules apply, 90 degrees, but they will only touch the surface, as you can see right here. These are, of course, all 90 degrees. They do not cross each other. And there it is. Now, inside the sphere, the electric field strength, of course, is 0. So it only is going to touch, the electric field lines are only going to go to the outside. Now, conversely, now let's say we have a positively charged sphere. So we have a sphere with positive charges. And again, of course, they will always accumulate on the outer surface. So remember, PONI, a positive out. So now the electric field lines are going to be pointing outwards. And here they are. And they all point outwards. So now, after this, we have to look at now interacting, point charges. Let me open up a new one. And so this one over here is going to be interacting point charges. So we have three different types of interacting point charges. The first one, of course, it is going to be, let's say, negative and negative. I'll try to draw small so I can fit all three of them right over here. So negative and negative. Remember again, our mnemonic, of course, I'm going to put it over here. It is pony, just like that, okay? So negative, of course, is in. So we're going to draw field lines, and they're going to go in just like that. And remember what we said, they always go to the surface by 90 degrees, and they never, ever, ever cross each other, as you guys can see over here. So again, here we go. Here are three more, and these are two negative charges that are very close to the vicinity. Notice how, like right over here in the middle, the field lines, as they go in, they bend. And that is, of course, in order to avoid each other. And now you can see why, for example, two negative charges will simply repel each other because their field lines can never, ever, ever touch. Now, the next one, of course, is going to be two interacting positive point charges, okay? Remember, pony positive out. So now electric field lines are going to come out of the positive surface, and again, they cannot touch. That's why they're going to curve up, and these over here are going to curve down. Again, same rules apply. They leave the surface at a 90-degree fashion, just like this. So they leave the surface 90 degrees, just like that, and of course they never touch. So the field lines between 2 point charges, you're going to have to bend them just like that. And of course, if they're positive, they're going to bend away. But over here, if they're negative, they're going to bend towards the charges. And the final interacting point charge that we have is, of course, between a positive and a negative. That's very easy to see what's going on here. Pony, positive out, negative in. So electric field lines now go out of the positive, and of course, they go into the negative. And of course, we have field lines going on the other side, but they don't have a negative charge. That will simply bend it towards it. And of course, we have electric field lines on the negative side, and of course, they go in. Again, notice how the field lines did not simply touch each other, and of course, they originate from the surface at a 90-degree capacity. And the last one, last but not least, that we have to speak about are between charged plates. So these are now electric field lines between oppositely charged plates, of course. Okay, so let's check this out. This is a special scenario. So let's say we have one plate over here. It's got to be a metal plate, obviously, because it's got to conduct electricity, and a negatively charged plate at the bottom. So up here we have the positive charges accumulated, and down here we have the negative charges that are accumulated. So let's draw the electric field lines over here. Again, same concept emerges. Positive out, negative in, pony. So the electric field lines are going to literally originate from the positive, and they're going to enter the negative. Now, if you notice carefully, these lines, these vector lines, are the same size, and the plates are equidistant with respect to each other. So what does that mean? It means that the electric field is the same. So the electric field strength is the same everywhere. So what does that mean? A very popular question is, of course, they give you at a point A right here the electric field strength, and we saw from the previous video how to actually calculate this. So let's say they tell you that it's 5 newtons per coulomb, and they ask you, let's say now right over here at point B, what is the electric field strength? Well, guess what? If it's between the two plates, as they are over here, it is going to be exactly the same one. So the answer, of course, is going to be 5 newtons per coulomb. And it doesn't matter where they are, as long as they are between the plates. It could be here, it could be here, 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 here. The electric field, of course, is the same. So as we said, the electric field strength is the same everywhere. Now, I want to also point out the following fact. Notice how the electric field lines are going from the positive to the negative. But now, a lot of times, they can ask a question such as the following. So let's say they put a negative charge here, and let's say they ask, how do the electric field lines, or will originate? They will go, as we said, from the positive to the negative. But if they ask you which is the direction of the negative charge, you have to say that it goes up towards the positive, because as you know, opposites simply attract. So that's basically it. Those are all the scenarios that we have, and now you know how to actually draw electric field lines. Thank you. See you later.